So this is a bass, and you can probably understand why I didn't bring it into school, because it wouldn't fit into my locker. But there's some cool things about it that we're learning about in physics that I can demonstrate. The bass has 4 strings, G, D, A, and E, but my bass is special because it has this thing called a C extension, and what it does is it makes the note that I can play with the lowest note that I can play a lot lower. So instead of this, I can play this, which is pretty cool. And so, like Mr. Nelligan was talking about, the strings, like in a cello or a guitar, vibrate and make the noise. These strings are made out of steel, however some strings can be made out of gut or synthetic kind of gut, like some kind of rubber or plastic. And this string, I don't know if you can tell here, I'll come up closer. So this string is a lot thicker than this string, and because it's a lot lower, it vibrates less, and so even though they all have the same wavelength, well, except for the lower one, virtually they all have the same wavelength, but because they are different tensions and different sizes, they make different notes. What I usually use to make a noise on this thing is a bow, and it has horsehair that really resonates against the string and makes it vibrate better. Then here's the low note, which I really like to play. And I'm going to come up closer so you guys can see the string really vibrating, because you can really see it on the bass, which is nice. And then on the G. You can see that one less just because it is smaller and vibrating faster. But, and so like Mr. Nelligan was saying as well, you can also play different notes by pressing down. When I press down, I'm altering the wavelength, which is then altering the frequency. So, like that. But what I wanted to talk about, what I wanted to show was harmonics. So when Mr. Nelligan said that like harmonics are a thing, he had said that you press down on the string, which with a guitar may be true, but with stringed instruments like a violin, cello, and bass, you actually just touch the string to stop the vibrations. And and like he said, there are also harmonics. There's a series of harmonics on each of these strings located at like the halfway point, the kind of quarter point, and it's what we call the harmonic series. So this, for example, is a G. That's just plain old note. I'm going to play the G harmonic. So it's the same note, but it's an octave higher because I've essentially cut the string in half, and because of that, gone up an octave. And as you can see, I'm just touching it and allowing it to truly vibrate on both sides of my finger, whereas if I just press down, there's no vibration behind my finger. And so this is really useful when tuning, because there's a harmonic here as well, and that harmonic here corresponds to another harmonic on a different string. So when I'm tuning, I can figure out if one of my notes is in tune, and then I can compare it and tune likewise. Some other harmonics are here. That's the same G, but just that's the quarter harmonic because it's another octave higher. So we have this, and those are all the same note, but just at different frequencies. Something cool and the harmonics go all the way up the string and all the way down the string as well, on either side. Typically we play harmonics up here. Yeah, up there they get kind of sketchy, but you can also play them down here, but they're significantly harder just because the source of the vibrations is so far away from it. Well, that one's pretty good, but yeah, and they're also just not very fun to listen to. But something cool that I can show you is something that we call the seagull trick, where using harmonics I can make my bass sound like a seagull, which wouldn't make much sense, but here we go. I'm going to do it again. So what's happening is I'm holding the string down with my thumb, and then I'm just touching it with my ring finger to create a harmonic. And because there are different harmonics and the nodes are happening at several different places on the string, each time I get to one of those nodes, it sort of restarts and adjusts the frequency likewise. So yeah, that is... Oh, something else, resonance. So, we use this actually a lot to our advantage in music. And so resonance, like he said, is when something of the same frequency kind of forces another thing of the same frequency to vibrate. So I'm going to use that. I'm going to get closer so you guys can hopefully see it. And I'm going to play a G. And I'm going to play a G on this string by pressing my fingers down. And if I'm playing it right, it should make this vibrate because this is a G as well. Let's see. Yeah, so I don't know if you guys could tell, but here it vibrated a little bit, and that's what's going on with resonance. Even though these aren't technically the same note, they're an octave apart, they do have the same fundamental frequency, and so they can, it resonates. And we use this a lot too when we need to do vibrato, which is where we rotate our fingers to kind of create a tone and change the pitch slightly. But say we're playing a note that's on an open string where we can't push our fingers down to do it. What we do is we play that note and then create resonance and then do vibrato. So it's called sympathetic vibrations. But yeah, so that is the bass. It can also be amplified. I have this little wire here that even though it's not electric, there's this copper plate that picks up the vibrations from both the body of the bass and the bridge where my strings hit, and it can be plugged into a loudspeaker. So I use that for jazz music, and you could use it for rock music, but I don't. But yeah, that is the bass. All right.